Hi there. I'm here to tell you a couple tips on how to make a great lab. These are things that nearly every student makes a mistake on, so I think it's going to be really helpful for you to listen to these. So the first thing is when you're choosing a variable to change in your experiment. Okay, when you're choosing a variable to change in your experiment, you've got to make sure that that variable can be measured, okay, and that you can change it incrementally and measure each little change that you do. So for instance, let's say that you think temperature affects the size of a balloon. Okay, so there's a couple things you have to measure there. You have to measure the temperature, and you have to measure the size of the balloon. Now, the reason why this would be a good variable is that you can measure the temperature change. So from one temperature, you've got a number there. You can change it to a different temperature, you've got a number there. And you can change it to a different temperature after that, you've got a number there as well. Each step along the way, the temperature can be measured. So the variable can be measured, and it's just slowly increasing or slowly decreasing. Or you can make a big jump if you want to, but it's increasing or decreasing. The variable can be measured, and it can be turned up or it can be turned down, so to speak. Also, you've got the measurement there that you can see the direct results from that temperature change. So you can measure the maybe the I don't know, the circumference of the balloon that you're measuring, see if it expands or it decreases or whatever. You can get a direct measurement from the temperature change to see if there's any difference in the balloon size. That's just one example. Now, I'll take the same kind of example. Let's say we want to change this balloon. I don't know why I'm choosing balloon, but it's the first thing that popped into my mind. Let's say that we want to, you've got a different idea. Like, oh, no, I don't want to do this temperature thing. That's no good. What I really want to do, I want to see if the brand of the balloon makes a difference to how big the balloon is when it gets at a certain temperature in the house. Okay, so you get a whole bunch of different brands of balloons, and you blow them up, and then you wait and see if they, or maybe you change the temperature or something, I don't know, but whatever it is, you want to see if the brand of the balloon affects how big the balloon is. Maybe I'm thinking about that. You'd have to somehow measure the amount of air that you'd put into the balloon to see how big it would expand, whatever. Now, the reason why this is not a good experiment is that the brand is the variable that you're changing. Okay, the brand is the variable you're changing. The brand of anything, or the type of anything, that happens all the time. People change the types of things. You can't gradually increase or decrease the type of something. So, for instance, if you let's say that you have one brand of balloon and you want to choose a different brand of balloon to see if it affects anything differently. Well, it could change, but it could be because of something inside the balloon that the brand is using over here, and then a completely different setup for a different brand over here. But you don't know what's really causing the change. You say, oh, the brand caused the change. Well, the brand is not the change. It's the materials inside that are making the changes. And you have no way of gradually increasing or decreasing those materials like you do with temperature. Temperature is so much more basic. It's very direct. You can see if you gradually increase it or you gradually decrease it. You can measure that. You can't gradually increase a brand or decrease a brand, so it's going to be difficult. In other experiments, you could do something where you gradually increase the amount of something. Let's say that, like, in future experiments, I think we're going to have a future experiment where we could have, perhaps you could change like a mixture where you have like a certain percentage of sugar in something, and then you gradually increase that percentage of sugar and see if there's an effect. That will work. But you can't change just simply the type of something and then measure the effect. Because if you change the type of something, right, a whole different type of thing, then there's no way of gradually increasing it or gradually decreasing it. All right? So that's one thing that we want to make sure that we do in these labs is you gradually increase the variable, gradually decrease the variable. You can measure that variable, and you can measure the effect. That's one thing that we've got to make sure every single lab you do in this course and in science and in whatever class you go to, that's how you're going to be measuring your experiment. You're going to be choosing a variable that you can measure a slightly increase in the variable or a decrease in the variable, and you can see the effect. You can measure the variable, you can measure the effect. Now, the next thing is the same throughout. It doesn't really matter the program. The programs all have these kind of basic things that you can change in them. I'm going to go through some basic things that you all need to include in your graphs. So the way that the Pages describes graphs is not with the word graph, it's with the word chart. So I'm going to go up here and I'm going to click on chart. There it is, chart. And you will never, ever, ever use a bar chart in science class. You never use it. Never. Because you're never choosing types of things to change. That's why bar charts are so misleading. You never use these bar charts. That's a bar chart right up there. That's a bar chart right there. That's another kind of bar chart. That's another bar chart. This is just a filled-in line graph. We're going to go to this right over here or this over here. The best is this thing called a scatter plot right here. So I'm going to click on that. Boom. Okay? They call it a scatter. 2D scatter. You can do, can you do a 3D scatter? Oh, we're not going to try that. That's too crazy. Now they give you all this data right away, and you're like, what the heck is this? You've got 0, 3, 6, 9, 12, and 0 to 20, and you've got what is this? They just give you data. You're going to have your own data. Let's say that let's stick with the balloon example, okay, since that was the first thing that jumped in my head. The balloons. So we're going to go to edit chart data right away. I'm going to edit that chart data. Oh, there it is. And boom, you've got the chart data right there. You've got the X. So the X is this stuff, I guess, right here. And you've got the Y, and you've got 3 Ys. So you've got 3 pieces of data as your measurements here. So I'm going to, instead of saying May in this case, I'm going to say, since I guess the effect was balloon circumference, so I'm going to say balloon circumference in centimeters. Boom. Oh, what? I'm going to say circumference centimeters. Hope that works. There it goes. Maybe that was too long. And I'm going to just delete this, all this stuff in here. Let's see if they have an option for that. Yep, delete column. Say goodbye to June and July. Okay, so now we just have one set of data here. So we've got the X, and we've got the Y. This X, we'll use my example of the variable temperature. So let's say that we have a temperature that we have a temperature at, let's say the first one was at 40 degrees. The next one was at, don't worry about what's changing up here. I'm just putting in the values here. The next one was at, let's say 50 degrees. Just make it easy. 60, 70, 80, and then 90. All right, let's just say that we did it step by step in degrees. Now we don't have a title in here. They don't let you put a title in yet. We'll figure that out in a second. Okay, so far this is what's happened. And let's say the circumference, let's just, I don't know how big this would be in centimeters. Let's just say it starts off at 100. Let's just say it goes pretty well like this. I'm just making up data right now. You should always test this stuff. Let's say it's 115. Let's say this is 120. Let's say this is 122. Let's say this is 150. Big jump. Let's say this was 157. All right. Okay, so that's our data. Right. There's our data. It says circumference in centimeters. Okay, fantastic. Now, first of all, this is better than most charts that I get, is because it's not a bar chart. It's not a hand-drawn chart. But a couple things I want to draw your attention to. This axis over here, this is the x-axis. This is what your independent variable, the variable that you change. So this is all in degrees. Should be, at least. And this should be in, this is the circumference over here. So we need to make sure that we're labeling our axes. So over here, we've got the axis, and so I'm going to go to that. And it's on the x value. That's our independent value. Let's say we got to get a name here, so I'm going to click name. All right, I'm going to go click on this. This is going to be temperature. And it's in Fahrenheit. Okay. I want to look at my data again, because this is a little bit weird. It's got that. Oh, that's why we have this extra data over here. I'm just going to delete that. Bingo. Right. Fantastic. Now, I've clicked on this graph again. I did that quite quickly. Clicked over here, and we've got the axis again. We've got an axis line. Yeah, it's not a big deal. Axis scale is a linear. That's good. We can choose, in this case, we can choose logarithmic. That's by a factor of 10, but we don't need that. Now, they've automatically scaled this, which is pretty cool. I don't know what that means. No. Okay, let's just do auto. That's fine. And then they've got steps over here. Now, steps are great because it gives you more steps in between here, meaning that you can have more values in between here. It's automatic, so you don't even have to worry about the scale of this. It automatically sets it up as a nice scale for you. So each little gap in between here, from this to there, is 7.5. From there to there, 7.5. From there to there, 7.5. 7.5. 7.5. Blah, blah, blah. That's really good, because most people, they ignore this scale over here. They completely ignore it. You gotta make sure that scale is consistent along the way of that x-axis. So that's great. It's linear. It's split up by the number of steps here. It's automatic. It's all set up for you. Fantastic. Is there anything else we can do here to play around with this? Reference lines. Let's look at this. What does this mean? Oh, that's pretty cool. An average. It's not really helpful for us here, though. Can we take that off? What if I don't want one? Oh, no. Trash. There we go. Major grid lines. I like grid lines. Let's do them. Bingo. There it is. That gives you a sense of where these data are according to your x-axis. I like that a lot. Whew, we can make them smaller, too. That's nice. We can put a shadow to them. Ooh. Okay, minor grid lines. Now, what are these? Ah, those are the in-between. I like those as well. Those are nice. Make them even smaller. Grid lines are great because they can let you see where the data is a lot easier. Your eye can kind of deceive you. All right. Tick marks. I love tick marks. They're my favorite. So you can do this. So the tick marks are going inside. You can make them centered, I guess, or outside. Doesn't really matter. And minor tick marks. The more you can show where these values are on the graph, the better, because you can see exactly where this data falls. So you can guess right now that I'm going to do the same thing for this axis over here. I'm going to go over to my y-axis. Now this is very important. I love to have these perfectly spaced right here on both sides so you can see your data very clearly. And we're going to see some other cool things you can do along with this, but this is essential for 100% on your graph. You need to have your axes that are labeled. Here it is labeled. You see the unit that you're using. You see that this is scaled properly. We need to make sure that the other side is labeled as well. So let's do that. I just went over there and I'm going to say that this is circumference. I hope that's how you spell it. And we're going to say it's in centimeters. Kind of weird to write sideways. All right, that looks great. Let's click back on here and go back. Oh, it's already on our y-axis. Great. Axis line doesn't really make a difference, but what the heck? Might as well put it in. Now we can make these steps as well. Oh, look at that. Now we can see a little bit more detail. Let's do even more. 10. 10's good. I'm not going to give you a standard to do this, but it's the more steps you have along the way, the easier it is to see where this data falls. So the more, the better. I'll leave it to your discretion to see how many you want to put on there. All right, this all looks good. I'm just looking through all this right here. Okay, we don't need a reference line. Major grid lines, I like that. We can make that smaller or bigger. We can show minor grid lines as well. Oh, look at that. You put that on there too. I like tick marks. We like tick marks. I put those centered. It doesn't really matter if they're centered inside or outside. It's kind of minor detail, but you can see where this number lies right there. So you can see right here that this data falls between 128, and let's see, each one of these is 16. So that would be 8 in between there. So it's 128 and 120. That's where this data falls. It's really good to have these clearly labeled on both sides with scaled, meaning that each step along the way is the same distance in this measurement. Okay. Now, not too. Some people are really strict on titles. I don't really care about titles, but we can do titles if you want to. I think this one has an option for that as well. Title. Bingo. Title. We'll say temperature v circumference. Boom. All right. What else can we do for this? I'll click on this again. We can go to the series, see what this looks like. This is great. This does all the work for you. Back in my day, we had to make our own trend lines. But look at this. You can find a trend line. You can do a linear trend line like this, which is really, if you do anything beyond linear in high school trend lines, then you are super advanced. So we're just going to focus on linear. Linear is good enough. And we don't need to name it. We can show the equation. There it is. This is the y equals mx plus b. Boom. There it is. That's the slope right there. 1.12x plus 54.533. That means, what does that mean? What does that mean? That means that for the temperature starting off, you can give me any temperature, right? Let's say that you have, I don't know, you didn't measure this, but 75 degrees. 75 degrees, that's our x value here. We put that in, 75 times 1.12 plus 54.533, and we're going to come up with a value right there on this trend line. That's pretty cool. That means that we can interpolate and extrapolate from our trend here. This is showing a positive trend. If we increase the temperature, we'll also increase the circumference of the balloon. So trend lines are great when you have a trend. Obviously, when you don't have a trend, you can't really have a trend line. So that means that the data go too far away from this line. You can't really say that this is a trend. What it does is this averages all the data for you and makes this trend line for you, so you don't have to do any work. Whew, that's pretty cool. Now we have error bars as well, positive and negative. You could do this if you want to, and then you have to figure out what you want to have as this. This is a percentage, within a 5% range, a 6% range. If you know what your uncertainty is, you can figure out what your uncertainty is in a percentage, and then you can have this on your graph, and that is super cool for the, it wouldn't be for the x, I'm sorry, it would be for the y as your result. Okay, right. Let's say that's percent. Let's say that we know what our percentage. Let's say our percent uncertainty is 2.5%. Boom. Then we'd have this little error bar here. We can make these data symbols smaller too by just going up here and making them smaller. That's pretty cool. That shows our error right there. That's amazing. And that's beyond the scope of this class, but it's great to know that that's there, and you can get mad respect if you do that. Okay. So that's the basics here. The basics again was going through this with the scaled axes that are labeled on both sides, with a scatter plot for your data. So you can clearly see if there's a trend in your data or not. Since the whole point of these experiments is to see if there's a trend. If you increase such and such, does something else increase or decrease? If you decrease such and such, does the effect have a trend? So you want to see a connection between the variable that you're changing and the effect. And that's what this shows. It shows here's the variable you're changing. Okay, as it goes up, does the effect change over here? If it's a line that goes up, then yes. If it's a line that goes down, then yes. If it's a line that goes flat, then there's no effect in the measurement here. So anyway, I needed to go through this because so many people make mistakes when it comes to graphing, and you need to know how to graph to go on to college. You need to graph to understand graphs, period, when you're looking at articles that you're reading, so you can interpret what's going on there. If they don't have a scatter plot like this, they're not really showing a good trend. That's it for me. Good luck on your graphs. Good luck on your choosing of your variables. Below, I talk about how you can choose your variables, any variable you want. But I can tell you right now that if you choose the type of can, if you're doing this is for the ideal gas iLab. If you do the type of can, then you're not going to go get any kind of trend in your data because it's the type of can. Okay. Anyway, good luck. Let me know if you have any questions. Bye for now.